Okay, so on this particular figure, we have several things going on, and so it can look a little bit confusing at first. And basically what we have is we have two lines. Here's one line, and here's the other line intersecting. And anytime we have two lines intersecting, we have vertical angles and we have linear pairs. In other words, anytime I have two lines that are intersecting, the vertical angles will be congruent. And then any two angles that aren't congruent are next to each other in a straight line, where I can sort of cover up everything but the line and say these two are a linear pair. So these two add up to 180. Or these two are a linear pair. So these two add up to 180. So that's what I'm going to do. But notice I have two different variables. So while it's true that I could say these two add up to 180, let's go ahead and say that. It's perfectly true for me to say that 3x minus 5 plus 5y, equals 180. Well, that's a perfectly true statement. It doesn't help me that much right now because I've got two different variables, an x and a y, with only one equation. If I wanted to solve for two different variables at the same time, I would have to have two equations, and we call that a system of equations. But there's a simpler way on this one. Whenever you have a situation like that where you have two variables, look first and see if there's any way you could write one equation that only has one variable. In other words, is there a way for me to relate this and this because they both only have an x? And yes, those are vertical angles. Vertical angles are congruent, so I can say that these two are equal to each other. The 4x minus 25 is going to be equal to the 3x minus 5 because those are both vertical angles. Let's mark them. Okay, so then I can solve for x because I only have one variable, and that is perfectly doable. Collect my numbers on one side, collect my variables on the other side, and I have x is 20. So now if I know that x is 20, I could go back and I could plug in here, or I could go over here and plug in. It doesn't matter either way. I think I'm going to do it here and put a 20 in right there. And then 3 times 20 is 60 minus 5 is going to be 55 degrees. So now I can go back and solve for y by setting up an equation between these two. Those two are a linear pair. Basically, what we have is this. We have this is 5y, and this is 55. And so together, since they form a linear pair, we know they have to add up to 180. So 5y plus 55 equals 180. Subtract 55 from both sides, and I get 5y equals 125. Divide both sides by 5, and I get y equals 25. And there is my answer. Now, anytime you solve, meaning you find the value of a variable, you get x as a number, or z as a number, or m as a number, you always want to check and see if that's what you were asked for, or if instead maybe you were asked to go back and plug that in and find something else, which we were here. We were asked to find the measure of angle ABC. Not sure if you can see that. There we go. So that means I need to go back and look and see where angle ABC is. Here's angle ABC. Well, there's a bunch of different ways I could do this. I could say, well, ABC and the angle that we already know is 55, those are a linear pair. They're two angles on one side of a line, so they must add up to 180. So just subtract 180 minus 55. That's one option. Another option is 5y and angle ABC, are vertical angles. That's a pair of vertical angles. So if I know that y is 25, 5 times y is 125. So this angle all up here is 125, which means this angle down here, the vertical angle, also has to be 125. So let me move my paper down a little bit. And I'm going to say the measure, try to show more, here we go. the measure of angle ABC is 125, so that I have fully answered the question. And then I'm done.